Hi there. Today we looked at some more solids of revolution. And so we have here in number 1 we're finding the volume of the solid with the given boundaries and axis of revolution. So our boundaries are y equals x squared and y equals 4. And so if you put that in your graphing calculator, we get this region, y equals x squared and y equals 4. Let me shade that in so we can see what we're looking at. And in this particular problem, we're going to be revolving that region around y equals 4, which is our axis of revolution. Okay, and so that's going to be the orientation of our big R and our little r as we're forming our equation. So we have pi, the integral, big R squared minus little r squared. This axis of revolution is parallel to the x-axis, so this integral is going to be in terms of x. My bounds are going to be the x bounds, this left bound and this right bound, okay, which are -2 and 2. And our big R is the distance from the axis of revolution as far as we can go. Upper minus lower, our upper here is sitting on y equals 4, so my upper is 4, minus my lower, which this is y equals x squared. My lower point is sitting on x squared, so this is minus x squared. And then minus my little r is the distance from the axis of revolution to the closest point, which if I start at the axis of revolution and I move to the closest point, well, I haven't moved at all. Starts on 4 and ends on 4. 4 minus 4 is 0. Right? So essentially I'm doing pi -2 to 2 of 4 minus x squared dx, because this 4 minus 4 is 0, squared is 0. Okay, and so if you take that and you plug it into your calculator, you go to F3, integrate. We're going 4 minus x squared, quantity squared, comma x from -2 to 2. You should get 512 pi over 15. So again, big R, little r always come from the axis of revolution, and it's always upper minus lower. All right, we're finding the distance between those two graphs. Okay, so number 2, same thing. We're finding the volume of the solid. We have y equals 2 minus x squared. That's my y equals 2 minus x squared. And y equals 1. And we're revolving it around y equals 1. There's my shaded region. Pi integral big R squared minus little r squared d something. So that's just kind of setting up the problem here. So we're looking at our axis of revolution because that dictates, well, what our r's are going to be. It dictates what our bounds are going to be in reference to. My axis of revolution is parallel to the x-axis, so I'm going to be doing dx, and I'm going to be looking at the x-coordinates, which in this particular case are -1 and 1. The x bounds, -1 to 1. Okay. And my big R is the distance from the axis of revolution to the furthest point. And then upper minus lower, my upper point here sits on the quadratic, which is 2 minus x squared. My lower point here sits on y equals 1. So upper minus lower. My small r is from the axis of revolution to the closest point, which it hasn't moved at all. It started on 1 and ended on 1, which is 0. There's no distance between the axis of revolution and the closest point of my shaded region. So then we go to our calculator, and we plug in the integral of 1 minus x squared from, or of x, from -1 to 1. which is 16 pi over 15. Just a reminder, 84s, you get this syntax from hitting math and then number 9, which says fn int. And that's shown on a prior video. Okay, number 3, we are finding the volume of the solid with the given boundaries. So we have our y equals 2x squared. We have our y equals 8. But in this case, our boundaries are not the same as our axis of revolution. Our axis of revolution is separate from our region, because our axis of revolution is y equals 9, which is up here. That's my axis of revolution. But the formula is still the same. Pi integral big R squared minus little r squared d, and then we're going to look at our axis of revolution to help us determine bounds and what this is in reference to. So my axis of revolution is parallel to the x-axis, so it's going to be dx. And my bounds are going to be the smallest and biggest x of my shaded region. My smallest x over here is -2, and my largest x is 2. So big R, distance from the axis of revolution to the furthest point. My upper is on 9, right, y equals 9. My lower is on this quadratic, which is 2x squared. My small r is the distance from the axis of revolution to the closest point. And so my upper is here on y equals 9, and my lower is on y equals 8, which is the equivalent of -2 to 2. 9 minus 2x squared squared minus 1. Okay, so then we get our calculators, same thing. We have our 9 minus 2x squared, quantity squared, minus 1 dx from -2 to 2. We should get 896 pi over 5. Again, my challenge to you, because these notes are on my website, if you're starting to get it, pause the video, try one on your own, start it again when you are ready to either check an answer or if you've gotten stuck and you need a hint as to what the next step might be. Okay, number 4, we are finding the volume of these particular functions, y equals root x, y equals 0, which is our x-axis, and x equals 3. Okay, and in this particular case, we are revolving around the line y equals -2. That's our axis of revolution. So we have pi integral big R squared minus little r squared d something. Okay, this axis of revolution is parallel to the x-axis, so it's dx. And so our bounds are going to be the smallest and largest x in my shaded region. Smallest x is 0, the largest x is 3. Okay, big R, distance from the axis of revolution to the furthest point, and then upper minus lower. Upper, this sits on y equals root x. So this is root x. Minus my lower, this sits on y equals -2. Small r, distance from axis of revolution to closest point, so this top point sits on y equals 0, minus lower, which sits on y equals -2. Pi from 0 to 3 of root x plus 2 squared minus 4. And you plug all of that in. X plus 2, quantity squared, minus 4 dx from 0 to 3. Okay, we get 8 root 3 plus 9 halves, which is approximately, accurate to 3 decimal places, 18.356 pi. Okay, number 5, we have our region here, bounded by y equals x squared. And y equals 4. And then x equals 2. Which is our vertical line. Same formula, pi integral big R squared minus little r squared d something. Okay, in this case, my axis of revolution is parallel to my y-axis, so this is going to be dy, which means my bounds are going to be my lowest and highest y. My lowest y is 0, my highest y is 4. Okay, big R is the distance from the axis of revolution to the furthest point. Little r is distance from the axis of revolution to the closest point. Okay, now this quadratic is y equals x squared, but I don't want to use x squared inside my integral because we're doing with respect to y, and so x squared is not the same variable as y. So we want to turn this equation into an equation with y. Right, so I'm going to go ahead and square root both sides. So we have x equals plus or minus root y. The positive root y is this half of the quadratic, and the negative root y is the left half of the quadratic. So when I'm talking about my big R, I have my upper minus my lower. My upper is here at 2, right, because it's on x equals 2. My lower is on the negative part of that quadratic, so it's on the negative root y. Okay, minus my little r, upper sits on x equals 2. My lower sits on the positive root y. So we're at pi 0 to 4. Of 2 plus root y squared minus 2 minus root y squared dy. Okay, so then we plug it into our calculator. Plus square root y squared minus 2 minus square root y squared dy from our 0 to our 4. We should get 128 pi over 3. Okay, last one, number 6. We are finding the volume of the solid with the given boundaries. Y equals 6 minus x. X equals 0, which is my y-axis, y equals 0, which is my x-axis, and y equals 4, which is here. And I'm revolving around x equals 6. Okay, so we have pi integral big R squared minus little r squared d something, as determined by our axis of revolution. Our axis of revolution in this case is parallel to the y-axis, and so this is going to be dy. My bounds are going to be my lowest and highest y's. My lowest y here is at 0. My highest y is up here at 4. Big R, distance from axis of revolution to the furthest point. Little r, distance from axis of revolution to the closest point. Okay, so my big R, upper minus lower, upper sits on x equals 6. So this is 6 minus. Lower sits on x equals 0. Little r, upper sits on x equals 6. Lower sits on this 6 minus x, but again, I don't want to put 6 minus x in here because we're taking it with respect to y. So I want to go ahead and turn this into a y equation so I can add the x over and then subtract the y over. And so that's what I'm going to put in here, 6 minus y, which is the same thing as pi from 0 to 4 of 36 minus 6 minus 6, which is 0, plus y. Distribute the negative, dy. And we plug this in. 36 minus y squared dy from 0 to 4. We get 368 pi over 3. And that's my answer.